So we continue our discussion on functional dependencies and how to find candidate keys. Just a quick recap of what we did in the last video. I told you how to find the closure of certain attributes, right? Well, it was quite simple, and we did one question, which was this. And in the last lecture I missed this CD candidate key, so you may take a note on this. Apart from this, we will continue doing some more questions. So before continuing with the questions, um, I need to tell you that these were the steps that we had followed, and step 4 is something very important, and which we'll get to know in this video. So make sure you uh, give very much importance to step 4. Apart from that, just some abbreviations. Well, PA is the prime attribute. This is suppose if I say AB is a candidate key, then AB are the prime attributes, and CK is the candidate key. So before continuing with this video, now since that we have already done one question, so I would recommend you to take a note of these 5 questions which are on your screen. If possible, give all these questions a try and see what candidates key you get, and in this I'll try to solve all these 5 problems so that you can get well versed with it. So I recommend you to pause this right here and we try these questions. I'll continue with the with question number 2, which is this. So now what we need to do in this is this is the given functional dependencies. So how do step 1 would be, how do I start? I can start from anywhere, so let me start from A. Okay, so I'll try to take A's closure. So what it will be, so what do I get from A? I just get only A from it, so obviously this is not a candidate key. Now when I try for B, so what would be the closure of B? Closure of B would be B itself, right? Nothing more we can get from B, right? Similarly, C's closure would be okay, well, this is something better. So it would be C. This is known as trivial functional dependency. C can determine itself. It is also given C determines D and E, so I include this in its closure set, so it becomes CDE. Apart from that, what do I have from CD? Can I make anything? No, I don't think so. And from E, from E I can make F, so I include this in my in this C's closure. And from F I can take A. So okay, great. So what do I have? A, C, D, and from A, okay, so can we see anything apart from this? What I get from C? C goes to D, E, D has been included, E goes to F, F included, F goes to A included. Anything other than this? No, I don't think so. So we go to the next D. D's closure. What would be D's closure? Well, D's closure would be D itself. After that there is nothing which I can find. So now I try to take E's closure. I am just looking if I can get a single attribute candidate key, but I don't think so. We can get, let's see. So E's closure would be E itself, then F, E tends to F. From F I can get A, so I get A, EFA. But from EFA, using EFA, I can get anything else? No. So this somehow tells me that I need to, I mean, C gave me A, F, E, D, C, right? Only B was missing. So we can say that if I include B, if I give B to C, so then it can become powerful enough to become a candidate key. So, and in the, I told you already that our approach is to find the first candidate key, and then we can go about finding rest of the candidate keys very easily. So I can say that CB forms a candidate key. Okay, so how can I say this? Because if C gives me C, D, E, F, A, so the only thing left is B. So if I include B, then CB becomes a candidate key. Now things start becoming a bit easier for me. So how do, what step did I tell you? Now CB, right? C and B are the prime attributes. So our step would be search for C on the RHS of the given functional dependency. Do you find any C? Yes, yes, this is a C. So what do we need to do? We need to replace C by AB. So if I replace C by AB in this, what would I get? ABB, right? ABB. Well, before that, let me include CB in the candidate key set, just to make it a bit clearer. So if I replace C with AB, so what do I get? ABB, which is nothing but AB itself, right? So I can say that AB is a candidate key. Okay, so my next step would be search for B on the RHS, but I do not find any B on the RHS. So let's go forward. So now I have AB. So search A on the RHS. I find this A on the RHS. So what I do is I replace A by F. So what it becomes is uh, FB, right? Similarly, I search for I have already searched for B on the RHS. I search for F on the RHS. So here again I find F on the RHS, right? So again the same step I would take, that I would replace F with E. So this becomes EB, right? I hope you are getting what I am doing. So if I what is my next step? I search for E on the RHS. So do I find any E on the RHS? Yes, uh, this is basically C tends to D. I mean, you can write it. Please note that you can also write this in a way: C tends to D and C tends to E. So basically, you can replace E with C. So what would you get? Um, C comma B. Well, this becomes C comma B. But again, CB we have already taken in. We have already taken, so no need to take it again. So yes, that's it. We are done with finding the candidate keys for this question, and these are the four candidate keys. Let us move across with the third question. Even if you are not getting what I am doing, I still feel that after four examples you will understand what is going on in all these videos. So again, step one, I can start from anywhere, right? Suppose if I start from I try to take A's closure, what would it be? It will be A, right? It's not very helpful. Similarly, if I take the closure of B, what would be the closure of B? It would be again B itself. So okay, so similarly for closure of C, what would be the closure of C? Closure of C would be C itself, and then I can see C tends to D, so I include D, and then from D I can get E, so I include E. From E I can get F. Oh great. And from F I can get B. Wow. So these are the things I have got. So is there anything I can get from using all this? Okay, I can also get A. Oh sorry. For C, these are the only things which I can get. Yep. So this is also not working as a candidate key till now, so I switch to D closure. So D's closure would be D itself, then A from this, then D goes D tends to E, so I include E, E to F, so I include F, F to B, so I include B, and from A, and using these two attributes A and B, I can also get C. So wow, so this gives me A, B, C, D, E, F. All these attributes can be determined by D itself, so D is surely a candidate key. Now then, if I take the closure of E also, although now there is not much need of taking the closure, because somehow if I say A, B, C, D, E, F, G, H, I, J, K, L, so how can you go about taking closure for each and every attribute? Well, neither the such a long question will come in the exam, but still I would suggest you to uh, approach it in this way, that you get the first candidate key and life becomes very easy once you find the first candidate key. But still I'll try to take the closure. Re closure would be E, right? F from this, B from this, and EFB. Is there anything I can find other than EFB? No, I don't think so. Maybe you also need to check. A, B, C, D, E, F. F. What would be F closure? F closure would be F itself, and what? F tends to B, so B also. What else? No, I don't think so. Anything else can be in its closure. I hope you are very much versed with how to take the closure. So okay, so again we got our first candidate key. So what is the rule? What I mean, that is not actually a rule. That is basically a trick, you can say, to get your candidates key very quickly. So from I got this candidate key D. So what is the prime attribute? D is the prime attribute. Now search for D on the RHS of the given functional dependencies. I can see this, right? So what do I do? I replace D with C, and that would be a candidate key. Well, mind you, what happened in this is that, see, what my rule told me was to replace D with C, and that would be my candidate key. But while I was finding the closure, right, I somehow missed A again. So this is the power of this approach, that even if you miss something in the closure, there are high chances that you would not miss the actual candidate keys. So again, let us see what went wrong. While I was taking the closure, I took C, then I took C tends to D, okay, D tends to E, okay, E tends to F, okay, and F tends to B, okay. So what did I miss? I missed A. So but from using this D, right, I can get A, so I should have included this in the closure set, and that is why C is also a candidate key. So now I hope you are getting the sense of the power of this rule. So after that, what do I search? I search for C on the RHS. So I find C on the RHS? Yes, this is C on the RHS. So the candidate key would be AB. Right now, what do? I search for A on the RHS. I find this. Right. So what do? I replace A with D. So this becomes DB. Okay. Now say again I search for B on the RHS. I find this. So what do? I replace B with F. So this becomes AF. Okay. Now I search for D on the RHS, which is this. So I replace D, yeah, D with C. So this becomes CB, which is now these are the 6 functional candidate keys you have. So, do you find anything misleading about this CV? I mean, pause this video and think for a while that what is wrong with this CV if I say this to be a candidate key. Okay, so if you got the point, that is okay, but even if you did not get the point, what is wrong with this CV, let me tell you. So what was the point we discussed in the starting of this video was this step 4, that make sure all your candidate keys are minimal, right? But now here, using our replacement rule, we kind of said that CV is a candidate key, but as we can see that C is already a candidate key, right? And we are again saying that CB is a candidate key. Is it not something like saying, I mean, suppose if I simulate this, suppose I say C is a roll number and B is a date of birth. Just an example I am giving you, and I am saying that from roll number I can determine any student, and then again I am saying that from roll number and from date of birth I can determine anybody. So this is non-minimal, right? So this violates the minimal key property, that it should be minimal. So there there is just no need of this B in the in this CB, right? C alone can actually determine everything, so we need to remove this, right? Okay, now similarly the case for DB. Again, D can determine everything by itself, then why is this B coming here along with it? So this makes it non-minimal, so we again remove it. Now is there anything that is left? So I had already searched for D on the RHS, I already searched for C on the RHS, I already searched for A, I already searched for B. Okay, now what is left? F is left, right? I search for F on the RHS and here I find F. So what my rule says is that I can replace F by E, right? So what it becomes is A E, right? Now these five are the candidate keys. Just in case you are missing any point, no need to worry, there are three more examples, so you will ultimately get to know it, so you do not need to worry about it. The main thing is that you need to note the fact that these should be minimal. Just for verification purpose, you can see, you already see that D can make you determine everything, C can make you determine anything. From A, B, if you use alone, A alone or B alone, you cannot determine everything, right? Similar is the case with AE, similar is the case with AF. If you use both, then only you can determine, but if you use either of them, you won't be able to determine every attribute. So that is how candidate keys work. So, and that is the kind of questions you would be getting, right? So you may call this a trick or whatever you can say it, but that is how questions are to be solved, right? So I hope you are clear with this point, and I'll continue with the next three questions in the next video. I hope you have already given them a try. Just in case you did not try, you need to try these three questions more, and I'll upload the how to approach these questions in my next video. Okay, thank you guys.